The person who is running dynamic simulation on an assembly might want the assembly put together in a completely different way than the designer might do it, who doesn't understand dynamic simulation. So over here we have a level of detail with dynamic simulation active. If I click on the master, it puts all of the fasteners in here, and if I click down here on this dynamic simulation level of detail, the fasteners are taken out. But I want to put the fasteners in. I want them to be included in the mass of the simulation. And so I'm going to come down here and I'll right click and turn on the visibility or unsuppress this fastener right here. Now this red part right here and this blue part and this blue part are grounded. They don't move, and so this is welded to the frame of a truck in the back, and this is welded to the frame rail, and then this would be welded somewhere under the frame of the truck to the bottom of the frame. And I think what I'll do is to simplify this, we're going to clean up some of this to make it easier to follow. I'm going to select these three components, and I'm going to right click and I'm going to add those to a folder. And so I'm tempted to either add those to as a subassembly, but they're not really a subassembly by themselves per se. And so I'm going to tell it to add to new folder, and I'm going to call that folder grounded. I might call it grounded components. Now the fastener here would be added after this hydraulic cylinder is put in here, and so I could leave that as a subassembly, and I'm just trying to decide whether I want to do that as a separate folder or if I want to leave it as a subassembly. I guess I'll leave those as a subassembly. Alright, and then I'm going to turn off the visibility of those components for now to get those out of the way. So I'll right click on the grounded components and I'll turn off the visibility of those. Once that's put into the assembly, it is grounded too, so let's make sure that it's constrained such that it can't move, and we see that it isn't constrained. So I'm going to have to turn on the visibility of the grounded components, and we'll have to put that constraint in. Now we could have just grounded that in place since it was in the right location, but I'll just go ahead and insert this onto here, and I'll say OK to that. And we've also got this fastener that we need to get, and it might be a little bit difficult finding a location where maybe I should put that in first so I can see it through here. So I'll do constrain, and I'll do the axis of this fastener to the axis of the hole, and we'll say OK to that. And now if I try to move this part, it doesn't move, and so we have that one located. Alright, then I'm going to turn the visibility back off of that. So I'll turn off the visibility of that fastener, and I'll turn off the visibility of the grounded components folder. Now as we go through this, we're going to have to be really disciplined in order to avoid getting lost in how we put this assembly together. So there would be some hydraulic lines coming out the bottom of this manifold, and those hydraulic lines could catch on something as the truck drives over an obstruction. And so I think I prefer to move this cylinder, reverse it the other way around, so that the manifold is on the top rather than on the bottom. And in our part there was room for that to occur, so that's what we'll do. It turns out that this subassembly right here is upside down. This portion of it needs to be flipped around, but this portion of it needs to be in the same orientation where it's at. So the idea is when this unfolds, this angle is flat against the ground, and so it has to be turned around so that it unfolds properly. I'm going to temporarily turn off the visibility of the hydraulic cylinders, so I'll turn off those cylinders, and I'll turn off this cylinder and the piston that goes with that, and so that those aren't visible for now. And then I'm going to turn on the visibility of the fastener's second jack. And actually that was the one that we set down here, so that one's okay. And let's go down to the frames folding pins. I'm going to unsuppress those. So those are all of the pins that go into this subassembly. Now these pins and fasteners are all part of that subassembly, so I'm going to move those into this subassembly. If we zoom in on this also, we'll notice that some of these fasteners are not lined up correctly. See, this fastener right here is not lined up correctly in that hole, and I think the same fastener over on the other side, that's not lined up correctly with the hole, and I see this one is not lined up correctly with the hole either. So we have a bunch of errors that the original designer made that we have to take care of as well. Let's temporarily turn off the visibility of this subassembly. So I'm going to turn off the visibility of that subassembly. And I see that I have some fasteners left here. I want to put this one with that previous subassembly. And let's also turn on so that's the pins. I'm also going to turn or unsuppress the fasteners, bolts and washers that go with those as well. Alright, so I need to decide how I am going to handle this. I think I want all of these fasteners in with this subassembly, and I want these fasteners right here in with the main frame. So I'm going to, this might be easier if I rotate around lengthwise like this. So I want to move these components into this frame main assembly that we turn the visibility off. So I need to find those components first. Now if I select on that, it's going to find everything in that subassembly. So I'm going to shift right mouse button, put it on part priority. So I put my selection filter on part priority, and then I'll crossing window and be careful only to get these components. And I'm going to then move those components up into the frame main. So I'm going to drag that, and I'll have to expand that frame main first. So I should have done that. Cancel out of this, and I'll expand that frame main that I have turned the visibility off on. Okay, and then I'm going to drag these components and I'm going to put them up into this frame main. It'll give me a warning that I might lose some assembly constraints. I know that. I'll say yes to that. And so now those components are in this hidden frame main. If I turn that back on, frame main, if I go to the visibility, I have now moved these components into this subassembly. I'll turn that back off, frame main. And then I want all of the fastening components that are in this, or they're actually in these two separate assemblies. I'm going to move those into this frame folding. So I'll expand the frame folding, and then I'm going to select all of these fasteners. So I'll select the first one, hold down the shift key, I'll select that one, and I'm going to click and drag, put those up into this subassembly. And I don't have anything left in this frame folding pins, so I'll delete that subassembly. And then I'll go to this frame folding fasteners. That's the screws and the washers. And I'm going to select the first one. I'll go down and I'll select the last one. And I'm going to then move those up into this subassembly. So I'll click and drag those into this subassembly. I'll get a warning about constraints, and I'll close down this subassembly. And so now I don't have anything in this frame folding fasteners folder anymore, so I'll delete it. Alright, now I want to open up this subassembly because we saw that some of these components aren't in the correct location. So I'll open that and edit that one next. Save often as you're making these changes, and I might save this as revision 1, revision 2, so forth, so that if you make a major error you can go back to an earlier revision without having to undo everything. So your last correct version you can return to. Okay, so I want to edit this subassembly to make some changes. So I'm going to right click and I'm going to open this subassembly, and when I check where the origin is at, it's not in a logical location. I'm worried though that everything, it might not be constrained properly, so I'd like to just leave it where it's at and avoid having to rebuild the entire assembly. So most everything is going to be grounded. The only thing I need to do is fix these pins that are in the incorrect location. So I'm going to go to a view of it, actually from the front view, and I want to select everything except for these pins. So I'll do a crossing window, and I'm going to then right click and I'm going to do ground. Now some of those are already grounded, so if I do this, it's actually going to unground those, and I need to select it. I need to right click and do grounded again. So I'll do grounded a second time, and now all of those components that I selected are grounded. We won't accidentally move those. Now these components that are in the wrong place, I do want to move those and then reconstrain those. So I see that that part is grounded, so I'm going to unground that component, and I'll move that, and the fastener. So the washer is the part that's grounded. Alright, so there, that washer's grounded. I'll unground that, and so I'll move those out, and I'll move those. Alright, now I can constrain this, so I'll do constraint and I'll do insert. I'm going to insert onto that circle, this circle, and I'll apply that, and then I'll insert this circle onto this circle. It moves it over, so now it's in the correct location. And then I'll do insert one of these fasteners. I'll get the clamping face on this fastener to here. I'll apply that, and I'll get the next one, get the clamping face here, apply that, and I'll get the last one, I'll get that one and this one, and I'll say OK to that. So I have this one in place. Now I need to get this one in place, and it might be easiest if I turn this over. And so I'll attempt to drag this component out, and we see that it's not constrained, and we see that's not constrained. So I'll do constrain insert, and I want to insert into this hole, this circle, and then I want to line these up. So I'll select this circle and this circle, that lines those up, and then I want to put the fastener in here, the clamping face of the washer into that one, so that one's lined up. Alright, so we've got one more to go, and so I'm going to just drag this out of place. We see that it's not constrained, and I'll drag this fastener out, drag this fastener out, and drag that fastener out, and I'll constrain that. So I'll do insert this circle to the clamping face, I'll apply that, and I'll do one of these circles at the bottom of that hole to the top of this hole. I'll apply that, and then I'll put a fastener in there. So we'll get this fastener, apply that, and get the next fastener, apply that, and one more to go, and I'll say OK to that. And so now everything is in place and it's fully defined. Now it might be worthwhile to set up some folders for these fasteners. I'll just leave them where they're at, but if we wanted to clean up the clutter of this browser, we could create some folders. I'll save this, and then I'll go back to my main assembly. Alright, so now we've lined everything up and we have constrained everything in this frame folding. I'm going to turn off the visibility of this subassembly, and I'm going to go back to the frame main, and then so I need to flip this over to the other side, and I need to constrain this pin. And so I'm going to open up. Now before I do this, when I flip this over, it's going to change a whole bunch of different constraints. So I'm going to go to my relationships, and there's actually some others that are really not in good position. So I'm going to delete, and we'll go back and put these in again. I'm tempted to keep these initial positions, but I guess I'm going to just do this from scratch. So I'm going to delete all of these constraints, and we'll put them in ourselves. Alright, now I need to open up this subassembly, so I'll open that, and I want to ground all of this stuff, everything except for this, which I need to flip the other direction. So just like we did in the last problem, I'll do crossing window, being careful not to get this. So I'll do a crossing window, select all of this, and one of the parts is grounded, so when I right click and do grounded, it's going to unground everything. I right click and I do grounded again, And so now all of those components are grounded, and I like to move those together like that. And then these components are not grounded. So if I move that, we see that these components are not grounded. I'm going to put this pin into that. So I'll do constraint insert, and I will that circle, this circle, and I'll apply that and insert this circle to this circle. I'll apply that and then put the fastener in here, and so I have that. Alright, now I want this face to be mated to that face, so I'll do constraint, and I'll select this face, and I'll select this face, and I'll apply that. But I need to flip this around, so I want this face down here to be flush with this face up here. So I'll put it on flush. I'll select this face. I'll select this face down here. It will flip my part over. I'll say OK to that. And then I need to center this part up. But if we look at where the coordinate system was, for some reason the coordinate system is out in space someplace. It would be really beneficial if everything was modeled with symmetry about the origin, but it's not. If we open up this part and hope that it has a plane in the middle of that part, and we go through it and we see that it doesn't have a plane in the middle of the part. So we'll do that. We'll add a plane between this face, I think I missed it, between that face and this face. Okay, so now I have a plane going through the middle of that part. I'll save this part, and now I have a plane here that I can mate to. We see that those are the same color, so we'll do flush. So if they're contrasting colors, so there's a light side and a dark side. If they were contrasting colors, we would do mate. If they're the same color, we do flush. So I'll do this plane flush to this plane. That moves it over into the center, and now this is all fully defined. I'll save this subassembly, and I'll go back to my main assembly, and we'll turn on the visibility of everything that we have so far. So I'll turn on the visibility of the cylinders, and I'll turn on the visibility of the folding part of the frame and the fasteners that go into the cylinder down here, and the grounded components which we don't have visible. Now we've deleted all the constraints holding these subassemblies together, so they can be moved around now, and we'll reassemble this with constraints that will convert to the proper dynamic simulation joints. And we want to rotate this around, so I'm going to go to the free rotate, and I'll select this subassembly, and I'm going to rotate it around by eye. We don't have to worry about getting it exact right now. We'll get that later. And let me go ahead and save that change, and then I'm going to put these cylinders into subassemblies, and let's go ahead and move this pin into the grounded components folder. So I'm going to take that fasteners second jack, I'm going to drag that into the grounded components folder, and then I'm going to create a subassembly of these two components. And so I'm going to select those two components. I'll right click, and I'll do component demote, and I'm going to name this as second jack, and I'll set my units to metric units, standard millimeter metric units, and we'll say OK to that. Now let's open up this subassembly. Actually, let's create this one, and then I want to edit these subassemblies. So I'll select these two components, and I'll right click, and I'll do component demote. I want to demote those into a subassembly, and I'm going to call this first jack. And again, I'll make sure that my units are metric units. So let's rearrange things a little bit here. So I have the first jack, second jack. Actually, I guess that's fine. So notice that our browser is much cleaner over here with the various components that are going to be grounded and the components that move as subassemblies. So let's open up this first jack. and I will check and see where the origin is, and I see that it's out here in a place that I would not expect that location. And I'm going to also make sure that the parts are constrained together. So if there are any relationships already existing, I'll delete those, and then I'm going to do constrain, and I'm going to constrain the axis of the cylinder to the axis of this shaft. I'll apply that, and then I want to constrain the plane of this cylinder to the plane of the piston, and I can see that those two planes are the same color. See, there's a dark side and a light side. If they're the same color, then I want to do flush. If they were opposing colors, I would do mate. So I'm going to do this plane to this plane. I'll say OK to that. And so now we only have 1 degree of freedom translation. Now in the real world, before we put this subassembly into the assembly, this piston can rotate. But once we put it into the assembly with a pin going through here and a pin going through here, it can then only translate. It can't rotate. So that's what we want for a prismatic joint. Now I want to put this component in a logical location, so I'm going to unground that component, and then I'm going to go to the productivity tools, and I'll do ground and root, and I'll tell it to ground that to the assembly origin. And so we'll move the components back together again, and so now those are a location that makes logical sense relative to the origin of this subassembly. Now because we put these into a subassembly, we demoted those into a subassembly, we will need to make that subassembly flexible, and we'll do that when we go to put the constraints in. I want to do the same thing for this one, and so let's save the file, and then we'll do this one. So I'll save the assembly, and we'll edit this jack in the same way we edited this one. Now the manifold for this jack is out the bottom of the frame, and so we'd have some hydraulic hoses that come off of here, and they could catch on something, some obstruction that we run over with the truck. So I prefer to move this manifold up to the top, and there is room in the assembly to do that, so we will end up doing that. So I'm going to edit the second jack, and actually let's go ahead and open that. So I'm going to, instead of just editing in place, it'll be less confusing if I open that jack by itself. So here's our subassembly. I'll make sure there's no relationships on here. If I drag this, we see that it goes anywhere in space. I'll do constrain the axis of the cylinder to the axis of the piston, and so I'll rotate that around, and I need to find a plane going through this component, so I'll find the plane. So that plane, I'll constrain it to this plane. That lines it up. So now I'll have only prismatic or translational motion. And I also want to put this in the location relative to the origin. I see the origin is at a unusual place, so I'm going to unground this component, and then I'm going to ground and root, and I'll select that component again. So I'll do ground and root, select this component. I'll say OK to that, and move these back together. So now these are in a logical location in this subassembly, and I'll save this subassembly and go back to the main assembly. Again, we'll need to make this subassembly flexible when we put everything together. Alright, I'm going to free rotate that around, so I'll free rotate this around till it's approximately lined up. We just move it over here, and we're ready to start assembling our various subassemblies. Before I do that, I'm going to turn on the origin geometry. So I'll go to the View tab, and I'll go to Object Visibility. I'm going to turn on User Work Planes, User Axis, User Points, and I may or may not turn on the All Origin Planes and the axes and points. Some of the points were created in, or the assemblies were created in unusual locations. It might just be confusing if their planes are visible. But I want to make this axis mated to that axis, so I'll do constrain, and I'll select this axis, and I'll select this axis, and so we see that that's in position. Now when we're doing this, and actually I wasn't expecting this part to move around, so I got to figure out, I must have undone a constraint at some point. So I'm going to turn on the visibility of that housing and make sure that I get this part constrained in here. I'm not sure when I did that, but I think I went through and I deleted all of my constraints, so I need to put that back in. So I'll do constraint, and I'll do insert, and I'll select this circle onto that circle. And then I remember before we had trouble, I'll have to move that a little bit so I can see that, and I'll constrain the axis of this to the axis of that hole. Alright, so now that's back where it should be. Now I want to get this in the center of this motion so that it stays there in the center. So I'm going to hope that there is a plane going right through the middle of this component. So I'm going to expand that, and I see that that plane does go through the middle. So I'm going to constrain that, and I'm not sure whether it's going to be a flush or a mate. I will select it, and then I'll select this plane. And if it doesn't pop over into position, then I know that I have to put it on flush. And actually it's not giving me a good indication either way, so I'm going to just move this over here further like that. And I would actually prefer to get the plane going through the cylinder, and so I'm going to turn on the visibility of that plane that's going through the cylinder. And then let's also, just for good measure, let's turn on the plane going through this component. Alright, so we see those are the same color, so we want those to be flush. So I'll do constrain flush this plane to this plane. Now as we're doing this, it's actually a good idea to do this from within the dynamic simulation environment, and that way we make sure that we don't get ourselves in an over constrained condition. So let's go to, I'll save it first, and then I'll go to environments, dynamic simulation, and we are expecting to have a revolution joint right here. We see that everything is grounded. So let's go to simulation settings and tell it to automatically convert our constraints to joints. And now I see that I have a revolution joint here, which is what I was expecting. Alright, let's turn on the visibility of the lugs that get welded to the frame. So I'll right click and I'll turn on the visibility of the component on one side, and I didn't get that visibility. So I need to get the visibility and the visibility of the other side. Okay, so this subassembly gets mated to these two lugs. When we do this, we don't want it to be over constrained. So I'm going to do constraint, C for constraint, and I'm going to select the point in the center of this hole, and then I'm going to select the point. If I zoom in here, I see that there's a point in the center of this hole in this pin. I'm going to mate those two together. Now we know that that would give us a spherical joint at that location. And then I'm going to move this a little bit so that I can see those same 2 points over here on the other side. So I don't want this to be over constrained, so think of it as this needs to be able to twist slightly, and the point to point gives us 3 degrees of rotational freedom. But when I put one on this side and put one on the other side, we remove some of the degrees of freedom. So I'll do constraint, and I'm going to get this point, and I'll get this point, and I'll say OK to that. So then it gives us a point line on the other side. So this can only now rotate around the one axis. It has no translational degrees of freedom. It can't rotate around, in this case, the x-axis. But we haven't over constrained the assembly, because we would have a little bit of clearance between the pins and the fasteners that in the real world this could, around the x-axis, could rotate ever so slightly, but only a tiny amount. But if we remove that rotation, then with a insert constraint or on both ends, then it would give us an over constrained condition. Alright, then I want to put the cylinder or the piston here. I want to put that constrained to the pin here. Now we need to set this to be flexible in order for this to move. Now initially we don't need it to be flexible, but let's go ahead and set that subassembly to be flexible. So I'll go to my second jack and I'll right click and I will set it to be flexible. When I do that, it also puts a prismatic joint on here, and then I want to check though the direction for that prismatic joint. So I'm going to right click on that, and I'll go to edit, and I really want the z-axis pointing in the opposite direction. So I'm going to click here to flip the z-axis, and we'll say OK to that. And then I'm going to constrain this, so I'll do C for constraint, and I don't need an axis to axis because this right now is already set to only prismatic. And so I'm going to select the axis of this pin, and then I'm going to select a point. Any one of these circles will find a point on this part, and that moves those two parts together, and that will give us a point line at that joint. So that allows that a little bit of rotation in the real world. In the digital world, it's already constrained with prismatic on this piston. All right, let's move this component up, say about like that. We'll get it exactly 90 degrees here in a little bit. It might be a good time to save this, and then we can move on to the next set of joints. Next, I want to constrain this subassembly to this assembly, and we'll do this in the same way that we constrain down here. So I'll do constraint, and inside this pin, inside this little hole, there is a point. I'll select that point, and then in this hole there is a point. I'll select this point, and I'll say apply to that. That will give us a spherical joint at that end. And then I want to do at the other end, I want to do the joint, and it might be difficult. We might have to rotate things around or move things around where we can find it. We could do select other in here, but I'm going to just move this a little bit. So I'll move that up, and then I'll C for constraint, and I'll get this point down inside here. Now make sure it's not the center of this circle, not the center of that circle. We need to get this point down inside here and constrain that to this point. And so when I say apply to that, that's going to put a point line on the one side. So we end up with a spherical and a point line. And then we can put in the remaining jack. And let me go ahead and save this. And I'm going to rotate this approximately in the angle that I want first. So on the assemble tab, I'll do free rotate, and I'll rotate that up about like that. Whoops. And then I'll do C for constraint, and I want this axis constrained to this axis. I'll apply that. So that would give us a cylindrical joint, but I actually want that to be a revolution joint. So right now this entire subassembly can move side to side, so I want to constrain this to this. Notice that the planes are different colors, so this is a light color, this one's a dark color, so we'll do a mate. So I'll do constrain, and I will set this plane to this plane, mate it together, and so that gives us a revolution joint. Now before I constrain this, I want to make this flexible so that we get our prismatic joint, and so I will go to the first jack and I'll tell it to set to flexible, and that gives us a second prismatic joint here. I want to flip the Z on that prismatic joint, so I'll right click and I'll go to edit, and I'll flip the Z, and this is so that we'll end up with some positive numbers rather than negative numbers when we move the position. And then we'll constrain this up to here. Now again, because we already have this set to prismatic, we only need either a point to point or a point line. So I'm going to do an axis of this pin to a point, and I could select the circle out here like I did previously, or it has a point in here. I can select that point and constrain that, and we'll say OK to that. And so that gives us a point line over here. And the most important of this is that we didn't get any over constrained conditions in our assembly. With an assembly with this many joints in it, it can be complex to get it all assembled without having it over constrained. I'll save it. Let's define gravity. So I'm going to expand the external loads, and I'll right click and do define gravity, and I'll unsuppress it, and I see that gravity has already been defined, so I'll go ahead and accept that. Now before we put in our positions, we need to get our assembly put into a home position. If you remember, when we put our components in a home position, they're locked, so we don't want it to erase all of our joints that we defined when we lock the assembly. So I'm going to finish dynamic simulation, or when we put it into the home position, and then we'll put an angle constraint between here and here of 90 degrees to get that first position. So I'm going to do C for constraint, or on the assembly tab you can do constraint, and I'll do an angle constraint, and I'm going to put an angle constraint between this face and this plane. Now we might turn on the predict offset. I hesitate to do that because this is one option which will stay on after you've selected that, and it can cause all kinds of problems. I'll go ahead and put it on, and then I need to select. I selected the two faces, and then it rotates about this pin, so I need to select the axis of rotation, and it shows me that that angle is 281 degrees, but I think I actually want that to be the complementary of that. Let's put this on 90, and that didn't work out correctly, and so I'll do 180, and that didn't work correctly, so I'll do 0, and that didn't work correctly, so I'm going to rethink this. And before I put my angle constraint on here, I want to get this lined up pretty closely by eye, and so I'm going to try to get this more or less straight up and down. And then I will do C for constraint, and I'm going to do an angle constraint, and the angle between this face and this face. And I'm going to turn on predict offset. Now it's not showing an angle here, so I need one more selection. It rotates around this axis, so I need to select that rotation axis, and then it predicted that angle as about 90 degrees, so that's what I'm going to put in, 90 degrees. Okay, and I'm going to call that home position 1, and I'm going to label that then suppress this. So before we go back into dynamic simulation, we need to make sure that we suppress that. Okay, and then I'm going to move this component so that it is more or less horizontal, and then I want to do a constraint between here and here, an angle constraint, so I'll do C for constraint, so I'll put it on angle, and the angle then between this face and this face, and then I also need to check the rotation, so it rotates around this axis. Alright, so it predicted that close to 90 degrees. I'll put it at 90 degrees. And while I'm thinking about it, I'm going to uncheck this so that you don't run into trouble. And I will name this home position 2 dash, and label this suppress this. So before we go into dynamic simulation, we need to suppress that constraint. Anytime we need to get back to home position, then we can just unsuppress those constraints. Now I want to get the position where this would be moved, the feet right here, all the way to the ground. Before we do that though, I also want to get the position where it is now. So let's go ahead and save this. So I'm going to go into a half section view. So on the view tab, I will go to half section. You may need to click on this down arrow. And I'll select this plane, and I'll say OK to that. And it might be easiest at this point to turn off the visibility of the plane, so I'll go to object visibility, and I'm going to turn off all work features, 2D sketches, construction surfaces, so that I can see this better. Now when I examine this, what I want to know is that distance from here to here, and also the same way I want to know the distance from here to there. Now I'm not sure where my coordinate systems is on our prismatic joints. It might not be in a location that dimension might initially not make a lot of sense, but we'll make sense out of it. All right, so let's go ahead and do the measure. We'll see what I mean when we get there. So I'll go to the inspection tab, and I want to measure the distance where it is right now between here and here, and I'm going to record that dimension. And then I'm going to do the same thing on this one. So I'm going to dimension that distance from here to here, and I see that that is 139.611. Now I want to open up this first position and then measure the distance from here to here again. So I'll go to the angle constraint for that position, and I'm going to edit it, and I'll change that to 0 degrees. So now this is straight up and down. I'll measure this distance. So I'll go to my inspection tools and I'll measure the distance from here to here, and I'll record that dimension. Then I want to see where this comes around and hits the ground. So to do that, first thing I'm going to do is do a sketch for the ground, and because we're in section view, I'm going to do the sketch back here on this face. So I want to make sure it's on this side of the section. So I'll click on that face and I'll do S for sketch, and then I'll come back around here to the front, and I'm going to draw a line across here to represent the ground. I'll finish that sketch, and the sketch became invisible, so I need to turn on the visibility. So I'll go to the View tab, and under Object Visibility, make sure I turn on 2D sketches. And I want to bring this down by eye to where it's at the ground, so I need to suppress this constraint. So I'll suppress it, and then I'll bring this down till it looks like it's horizontal. Now if we're in a parking lot, or we're in a barnyard or a field, some construction site, the ground isn't always going to be perfectly horizontal, and so I'm not worried about getting this an exact solution horizontal. I'll just do it by eye close enough. I've moved it a couple times, and so if there is my ground, I think that's close enough, and I'll measure that distance now for this piston. So I'll go to my inspection tab, and I'll measure this distance from here to here, and I'll record that value. Once I have that value recorded, I will go back to unsuppress this. That'll give us back to the home position on this one, and I need to put this one back at 0 or 90. I forget what it was. I'll find out, so I'll edit this one, and let's put that back to 90. And when I did that, some of my components flipped. I'll say OK to this and hope that I can get everything to flip back the way it's supposed to be. And I've had trouble with this happening before, and we'll see if we can find an easy way to solve that issue. I've never really found a really easy way of fixing that issue, but one thing that might work is to suppress those two home positions and then manually move this back to where it's approximately in a good condition. And that can be a little bit hard to do. You might need to ground a component. See, I'm having trouble getting that. So we'll do this one at a time. So I've got this one more or less back to vertical. I will unsuppress that home position 1. So I'll unsuppress it. And so it's back at 90 degrees. And then I'll get this one where it should be more or less. And then I want to put this one, edit it first to put it back to 90. So I'll edit that, make sure that it's on 90. And then I will unsuppress it. So I'll unsuppress it. And so that got us back into position without these two parts flipping over. So I guess the lesson learned there is to make sure these are both back to their edited to their home positions, manually put them more or less in the home position, and then unsuppress those. We don't need to see this sketch anymore for the ground, so I'll turn off the visibility of that sketch. Okay, I'll leave section view now that I know those distances. So I'll go to the view tab and I will end section view. I'll save it. Now we've set up our assembly at a home position, but it's really important before we go to dynamic simulation that we suppress these home positions, but don't move anything once we have suppressed the home position. So I'll right click and suppress this one. I'll suppress this one. I'll go back to dynamic simulation. So I want to lift this piece up. So in the real world, the operator would pull out this pin, and there's a pin over on the other side. They'd pull out those two pins, lift up this part of the frame, put those two pins back in to hold these together, and then they would lower it all down to the ground. So I want to lift this up first. So I'll go to the prismatic joint for this jack cylinder, and I will right click, and I'm going to go to the properties, and I have 1 degree of freedom translation. So earlier when I was doing the measurement, I said I wasn't certain where the origin was at, and so here we see that the origin is actually offset a little bit. We're going to ignore that position. It's only a small amount, and in the real world, when we were moving this anyway, we wouldn't be moving it to exact distances, even to the nearest millimeter. And so I'm going to go to edit and pose motion, and I'll enable position, and I'll click on the input grapher. And so I'm going to say over a time of 10 seconds that I want to open that up. So I will go from position 0, and then at 10 seconds, now here's where I refer to the numbers that I recorded earlier, and I may change those numbers. So the starting position 139.611 minus the ending position 6.077. Now if I hit the tab key, this is one case where it doesn't give you the formula. It doesn't keep the formula. I'm not sure if we could have named that, given it a variable name, if it would have stayed in there or not. I want it to hold it at that angle. So I'm going to add another point here, and let's say the ending time, let's say, is 35 seconds. Okay, so it's going to hold it in that position from here to here. And actually I want to make sure that that value is the same, so I'm going to Control C and Control V to copy that value. So it's going to hold it in a straight line in that position. And I'll go back to this one. I'm going to make sure it starts out. Actually, remember there was an offset value here, and actually now it's changed that to 0. We'll see how it goes. So I'll say OK to that. And the biggest thing is I want to make sure that first of all that it's going in the correct direction. If it starts to go down rather than go up, I'll stop it immediately. So I'll go ahead and play this. And I see that this piston down here is not holding in position, and so I need to set that one also. So I'll go to the prismatic joint for this piston, and I'll go to the properties, and I'll go to translation. Notice that it has an offset position to start with, and so that's going to make it a little bit difficult. Now there is an option here. We could right click and we could set this offset, and I'm just trying to decide whether I want to do that or not. Let's go ahead and give that a try. A better way of doing this. So I'm going to cancel out of this, and I'm going to go to simulation settings, and I'm going to set everything where it is now as the 0 position. So I'll set all initial positions at 0. I'll say OK to that. And now if I go to this prismatic joint and I go to properties, it is now at 0, and we could have done the same thing by right click and set offset, but that sets everything in the assembly. When we did it with the simulation settings, it sets everything at 0 position. And then I'll do edit and pose motion, and I'm going to go to position, and I'll go to the input grapher. Now for the first 10 seconds while this one is opening, I want this to remain where it is at the offset position. So at time 0, I'll right click here, set that as the initial position, that offset position. And then I want to dwell while the operator puts these two pins in. And so let's say till 15 seconds. We'll give him, he's got to be really fast and put those pins in both sides in 5 seconds. We'll just speed it up just to make the simulation go faster by only giving them 5 seconds to do that. Then I'm going to add a point here. And so after that 5 seconds, then we'll lift that down, and we're going to say, let's give them 10 seconds to do that. So let's go to 25, and then at time 25 I want to put in the second value that we measured, and that was 355.6 0.422, and the exact numbers don't really matter. We can adjust these once we get the mechanism moving, and I'll say the numbers that I recorded was 26.377. I'll hit the tab key, and then I want to put in another point in here. I'll add a point, and I'm going to say at 35. And then I will make sure that this number, so I'll Control C, copy that, make sure that number is the same number here, so it's holding that in that position. And then we need to set our time to 35 seconds. So we'll say OK to this and say OK here. We'll increase our time. See, the first 10 seconds is just to open this. It dwells for 5 seconds, and then it moves this down. So let's do this as 35 seconds. I'm going to decrease the number of calculations. Let's say 350 calculations. Again, if it starts moving in the wrong direction, I'm going to stop it immediately. So let's go ahead and save what we have now. Save often. Alright, now we're ready to simulate, and again, if it starts going in the wrong direction, I will stop it and flip a direction for a position. I'll go ahead and play it. So it first goes up vertically in the first 10 seconds, it dwells for 5 seconds, and then it moves down to the ground position over the next 10 seconds, and then it holds that position. Alright, then I want to display though the imposed force that was needed to do that. Now notice that some of the time it is the pistons are having to lift force, and some of the time the pistons are having to hold against gravity. As this is coming down, gravity is actually aiding or pulling this down to the ground, and so we don't want it to just fall down to the ground. We want the piston to keep it from falling. So we'll go to the output grapher, and I will go to the standard joints, and we'll go to the prismatic joints, and under the prismatic joints we will display the driving force required by that piston and the driving force required by the second piston. So if I click inside here and I go through with my left and right arrow keys, so the driving force for one of the pistons is to lift this up, and then the other piston is just to hold that against gravity. And then when it goes to the dwell position, it is stabilized, and then when we start to fall, then the pistons are holding against gravity. So that's why the forces are both negative on this side. The last thing we will do is put a force on here representing a tractor load on the part, and then we can do an FEA analysis on one of these pieces that holds it in the frame of the truck. Let's open up this part. So I'll make sure that my selection priority is on part priority, so shift right mouse button, part priority, and then I'm going to open up this part, and I want to put a point on here, let's say in the midpoint of this face. So I will go to point, center point of loops, and I'll select this loop, and so that puts a point here at the center of that face. I'll save this, and I'll go back to the assembly, and I need to turn on the visibility of my points. So I'll go to the view tab, and I'll go to object visibility. I'll say user work points, turn those on, and then on dynamic simulation I'll play this again so that it goes to the extended position. And then I'm going to put a load at this location, and it's apparently not going to let me do that while we're in simulation, so I'll have to rewind that, and we'll put this load on here. And so I'll do a force, and I want this load here. For the directional, I want it perpendicular to this face, which would be to the ground. So I'll click on that face. Now when we rotate around, it's going to be coming down this way, so I need to flip that direction so that it's going down this way. And then I want to put that in, not now, but until it opens. So I'll click here for the input grapher. and I want it to be 0 until it reaches 30 seconds. So let's put a point here at 30 seconds. So between the starting point 0 to 30 seconds, I want it to stay at 0. And then between 30 and 35, I want it to increase to 25,000 newtons. And actually, I got that in the wrong segment, so I need to put this one back to 0. Make sure I'm over here in this segment. I want that 30 and 35 seconds. I want that to go to 25,000 newtons. Also, I want to display that force, make sure it's going in the right direction, so I'll click here, display it. And I'm going to put a couple of zeros in here. I'm not sure how many I'll need. It's going to display it really large. And I'll say OK to that. Okay, so initially that force should be off. I'll go ahead and play the simulation. It goes up to the first dwell position, dwells for 5 seconds, and then it goes down. And once it goes down, then we see the force being applied of the tractor going up the ramp. I'm going to go to the output grapher, and so now the force of the cylinders are not even visible in here. They're still there, but the force of the tractor overwhelms the force on those cylinders. Now we can assume that those are just held in position. Once this is opened up, we're looking at the worst case condition on this piece and this piece over here. So we're going to do a search max on this. So I'll do search max, and actually see that most of the force is here, so the ground is supporting that. Let's check mark this at that time step. So we want to see we want to test this part at that time step when there's the most force on it. Alright, so I will then tell it to export to FEA, and I'll select this part. I'll say OK, and everything else grays out. We need to put the location of that force. It will be on this cylindrical face. We'll say OK to this. We'll rewind, go back to construction, and we'll finish dynamic simulation. We'll go to environments. We'll do stress analysis. We'll create a study, and we're going to do a motion loads analysis. So here we'll check motion loads analysis, and we have it at that time step, and we'll say OK to that. It tells us the part is grounded in dynamic simulation. It must also be fixed in the stress analysis. Apply the appropriate constraints. So we'll say OK to that. Alright, now so we see these twisting forces on here. Those would be difficult to calculate manually. I'm going to change the display of those. So I'll go to stress analysis settings, and here for the glyph display, let's try 2, and I'll hit tab key. See what that looks like. It didn't change it. I'll say OK to that, and it made those, maybe that's too small, so I'll go to that simulation settings. Let's do 5%. We'll say OK to that. Okay, so we can see the glyphs for those twisting forces, and then it's told us we need to put some fixed constraints on here. So I'm going to do fixed. So I'm going to assume that this face is welded, this face may or may not be welded. If we're going into a C channel, I'm going to assume that these two faces aren't welded. I'll select this face and this face as fixed faces that are welded to the frame, and then we can run our simulation. Now, of course, we should check the mesh, make sure that we have an appropriate mesh. And so then we can see our stress areas. If we go to the displacement, and remember that's in scientific notation, so minimal displacement, and we go to our safety factor, and we're fine on our safety factor.